That was very good. That's what Steve Elswick writes, based on, he took just excerpts from my materials and what have you that I had done. He does a good job. And now that I'm here, I want to thank Steve Elswick and the Exotic Research. I've been with, Steve has been putting on symposiums and conferences for almost, or maybe even over a decade now, and I've attended most of them as a speaker on various subjects with the technologies that Eagle Research has. And because of these symposiums, I've managed to meet people like yourself. Quite a few of them have been interested for personal sake, and some wanted to develop products and sell them and that kind of thing, and attend these kind of conferences so they can get something happening. Because of that, Eagle Research has gained notoriety, luckily positive notoriety around the world. And so Steve Elswick has been a major boon to myself and several other inventors, getting the technologies that actually work out into the marketplace and helping develop them by putting the inventors together with the people who can finance or provide other support for the technology, even if nothing else than admiration, so that the inventor feels good enough to keep going. Sometimes it's really tough because the life of an inventor is mostly failure, and it's only those one in 100 times when you're right, or even partially right, that it makes it up. And then after a while, I've been doing this since 1984, you gather together enough of those right things that the physics books and chemistry books don't teach, that you end up having a pile of things that you can do that when you step up to the podium, it starts to look impressive. Plus, Eagle Research has done something that almost no other inventor in the world has done. We don't patent anything. So what we do is we write books, very similar to this one here, which is called Water as Fuel Book 1. This is my latest book. We're writing another one I'll tell you about a little later. And with the Water as Fuel, as in other books, goes out into the world. And what I've done is I've done all the research over a period of time. In this case, this book was being researched for over 12 years. And I finally just got it written this last year. And by putting that information out into the world, suddenly there's huge amounts of information out there that even though I was doing the research, I was unaware of. And people immediately come and bring those items to my attention, which of course that's why I call it Book 1, because in my experience there's going to be a Book 2 and a Book 3, and it'll just continue. The various technologies that are outlined in this book have been developed since before the turn of the 19th century, where we're going 18th into 19th century, and now we're going into the year 2000, which I guess is the 21st century instead of the 20th. But so for over 100 years, some of these technologies have been known, but haven't been developed. And I'm not going to go into the reasons why they haven't been developed as far as suppression goes or anything like that. It's kind of redundant to concentrate on that kind of thing. But I will say that various inventors backyard people have struggled and made a little gain, and struggled and made a little gain. Some of the information has become public. Usually with inventors, they try to patent things, and therefore that means they have to keep their mouth shut, and therefore the public doesn't learn about what's going on, and there's huge resources out there, people who have gone to the grave with information that civilization desperately needs to raise our standard of living and make this planet a paradise. With this patent-free philosophy that I've developed for Eagle Research, that doesn't happen. When we develop the technology or rediscover it, or even just discover it somewhere else and then publish it, we are able to raise the level of that technology in the public domain, and then other people can take that and go for it. Just a quick little idea of how it works is that I put out a book from a central point. You could think of it almost as a cone, and it goes down to 100 or 1,000, in our case usually about 30,000 people. And in that group of 30,000 people, there may be 3,000 of them make responses in one way or another. Either they build the technology and discover things that I hadn't thought of, because I'm only one person. I can only think of so many thoughts in a day. and even though my business is thinking, that there's just so much a person can do, but there's all these other people out there putting in their perspective, and when all those perspectives come back up to the peak, it suddenly generates a whole bunch of new level of technology, which then we can write another book and we can send that out. So each person that put in his own perspective suddenly gets the gain of all the other people too. And all I do is act as the messenger. And of course I sort out the information, do a little thinking on it myself. So the Eagle Research System has been working extremely well and has really helped out a lot of these technologies. So combine that with Steve Elswick and these sort of conferences and symposiums and the tapes that are made and go out, we're able to do some serious education, and those people are willing to experiment, get the support that they really need. Now, we'll start with water as fuel. With water, because that's what we're here to talk about today instead of all the other technologies Eagle Research is doing, you can get a hold of our brochure with all of our other books if you write to Eagle Research at Post Office Box 118, Port Hill, Idaho. Port Hill is all one word, 83853. Or you can look us up on the internet at eagle-research.com. There's a hyphen between Eagle and Research. Water is an ideal fuel for a lot of different reasons. And I'll just list them here in my water as fuel book. What we're doing is water doesn't create any pollution. Water burning doesn't even create oxides of nitrogen if it's done correctly. In fact, in some situations it eliminates oxides of nitrogen that are normally produced in combustion processes. It's literally an unlimited fuel because when you burn it, it turns back into water, one way or another. There's several different ways that water can be used as a fuel, and when you burn it, it turns back into water. It can be easily applied to existing technology like internal combustion engines and furnaces in houses. And it burns fast and even for maximum efficiency. The water can be used in fuel cells, and also development of practical water as fuel technologies will virtually eliminate the need for war on this planet, because most of the war is fought over resources. Most of the resources have energy or food at this time. Most countries aren't fighting over space anymore because the space has been pretty well sharply defined. Each country has its own place, and they can expand actually by crossing boundaries by just moving their populations into other countries. So, but food and energy are what's starting to limit our population. People in this room are mostly familiar with Nikola Tesla. And Nikola Tesla's innovations are the only thing that allows our civilization to exist the way it does. Because of his ability, the alternating current and electricity, if we didn't have that, just imagine life without alternating current or electricity. We just simply could not sustain the kind of lifestyle that we have now. Now, the lifestyle that we have now is also dependent largely upon fossil fuels, coal and oil, petroleum products. Now, these products were put into the environment, I should say, built onto the planet billions of years ago. The problem with bringing them back into our environment now is that we're changing our environment. Now, this for the planet, it really doesn't matter. For us, it matters. Our civilization isn't built to, or ourselves aren't built to have the average weather, the average temperature of the planet rise by a few degrees. Or even, in some cases, it could cause another ice age, depending on what's happening. There's all different theories out there. Nevertheless, we're changing our environment by putting billions of tons of carbon dioxide into the air, creating a greenhouse effect, which even when I took my agriculture degree back when I was in my early 20s, even then the greenhouse effect was being discussed and suppressed, because when we took the tours of the meteorological stations, we asked specifically as agriculture students, what is the greenhouse effect going to do for agriculture? And no one would even discuss it at that point. And since then, it's become more and more prominent, but there's a huge amount of suppressed information on there even so. With water as a fuel, we don't have that problem. Water is inorganic. It can literally power, you can make as much of the fuel in different ways as you have the process to do so. You don't have to wait for crops to grow to make alcohol. You don't have to haul oil up from subterranean depths. And the thing is, as far as the oil companies go, they actually make more money processing oil into plastics and paints and clothing and a lot of other different things. They can even make plastic houses which will last for a century, and they just snap together. A whole house can be built in 3 days with minimal people. And all of these things that we use, our cars are built mostly out of plastic anymore these days. Even in Britain, I even saw a car that was entirely built out of plastic. It just had a few metal pieces in it for conductivity of electric, and that's otherwise the body, everything was just made, even tires, out of plastic. So plastic is a valuable resource that we're burning up. And I don't like that, as well as other people that start thinking about it don't like it either. And of course, then there's the other pollutions that are brought into effect. Okay, so water is an ideal fuel for a lot of different reasons. If we can develop it into a practical energy source, then it has all these advantages. Now, there's a lot of different kinds of technologies that have been researched in the past. The first one I'll talk about is using water injection directly in internal combustion engines. The water can be used as a catalyst, and one of the ways it's done is by the Ralph Gunnerman method, and he has a fuel he calls A55, which is a 50-50 mix of water and petroleum, and he uses a detergent emulsifier or binder to combine the water and the fuel together so that it doesn't separate and cause bad things to happen to fuel systems. Now, there's been a lot of different, gradually over a period of time, the key working parts of this sort of a system have become public, and I can give a bit of a description of how that's working now. I use a blue pen because that's water, right? What we have is in the system, you have a cylinder with a piston that's moving up and down, and the fuel is that's 50% water and fuel is introduced into the engine. Now they're usually doing this with diesel engines, but it works quite well with gasoline as well. It's just that the diesel engine application is more prominent in the kind of things that, for example, Caterpillar did a lot of work with Ralph Gunnerman to work on that. And what they did is they nickel-plated the inside of the cylinder, particularly on the cylinder head and sometimes on the piston itself. The nickel acted as a catalyst, which then allowed this mixture to burn most efficiently. Then, in some cases, they even put insulated spacers on the nickel plating so that this plate could be electrically charged, and that worked a little bit better yet. So they were able to burn 50% mixtures of water mixed with the fuel with the emulsifiers. And on the internet and in my book here, I give the references so that you can find the emulsifiers and all the information necessary to use this Ralph Gunnerman method for yourself. And any engine rebuilder or anybody that knows how to take a head off an engine wouldn't have too much trouble figuring out how to put this thing in place. But that's pure nickel, and it's the nickel and in some cases the electricity that helps make the actual fuel work. If you just put this in an unmodified engine, it will work, but not nearly as much. It won't get the same kind of power. which comes to another point. Whenever you're mixing water with a fuel, the water tends to have a dampening effect as well as a catalytic effect. What we're looking at is a higher BTU fuel you can put more water into, with longer carbon chains. And so with gasoline, it is possible to mix up to 50%. There's another technology where what they use is deionized water. Completely clean, what they call 100,000 ohm water. and mix that directly with the fuel. And in this case, an emulsifier would probably help as well. But what this guy is doing, this particular fellow, is he's putting the water, deionized water, into the engine separately from the regular fuel. Now, you can do this with just ordinary tap water, but the cleaner the water is, the better off you are. And there's waters that you can enhance in various ways. And so the first thing you do to enhance water is clean it, get the garbage out of it. The second thing you can do is there's various vortex technologies and orgone technologies that you can add energy to the water that wasn't there before. Water is an amazing sponge for energy. So you can have, if you clean the water and then add this energy to it, the water can actually burn on its own. But then, then that gets into the technologies like what's called the Joe cell, where they can actually charge even the air that's going into the engine. They even have engines, internal combustion engines running on just air that has this orgone charge in it. So but the water allows it to charge. The water absorbs the orgone energy much more densely than air does. So in this particular case, this particular person is using deionized water, or like I say, you can use the orgone charged water, that sort of thing, to put the water in separately. Even if you don't put any extra charge on the water at all you're doing is using direct clean water, so deionized or distilled water. You can run up to about 5 or 10% of your fuel you can replace directly with water. Now what this is intending, what you're doing when you're just replacing fuel directly with water, it has to do with some side effects of the actual combustion of fuel. What's happening is when fuel is burned in an internal combustion engine, there's actually two combustions. The first combustion because gasoline can only burn when it's in a vapor state, okay? So the very first combustion has to do with the amount of vapor, the gasoline that's vapor when the spark plug fires. When the spark plug fires, that's the first vapor fuel that burns. Then that creates the temperatures and pressures necessary to vaporize the rest of the fuel, and that fuel would normally burn. And the problem is that the process of vaporization and burning takes 25 milliseconds or longer. And at 2,000 RPM, you have 7 milliseconds between top dead center and when the exhaust valve opens. So even if you're firing before top dead center, you're going to be having flaming fuel going out your exhaust. So what happens is it burns exhaust valves. And this is unacceptable to even me. So what they do is they put in additional fuel. So the very first combustion fires, that vapor that's there when the spark plug fires, and causes the rest of the fuel to turn to vapor, which makes it, since they've added extra fuel, it actually quenches the fuel mixture. Okay? It's now too rich to burn. Gasoline can only burn in a certain range of air. So if it's too rich to burn, it quenches. So then it cools, there's only cool fuel going out the exhaust. But then you got a lot of hydrocarbons and gasoline vapors and stuff going out the exhaust. I've actually run internal combustion engines off the exhaust from other engines. I've run a 4-cylinder engine off the exhaust of an 8-cylinder engine. Simply taking the exhaust and run it right into the carburetor of the 4-cylinder engine and starting it up, and it ran just fine. Okay? So I don't believe in it. What they did is they added a catalytic converter. This is a great idea. Since we have to add all this extra fuel to quench the flame, and we can't have these pollutants going out in the atmosphere, we'll just burn the extra fuel in the exhaust. Well, that seems pretty ridiculous to me, particularly since another answer has been around for almost a century. Even in the early part of the century, when they were first having internal combustion engines, they used water as the quenching. And they got away from it. I don't know why. I wasn't back there then. I wasn't making policy decisions. But water does several things. The first thing is, ordinarily when you lean down an air-fuel mixture, your exhaust valves heat up. The exhaust heats up because you don't get this quenching effect from the extra fuel. But if you keep the vapor the same, take out a certain amount of the liquid gasoline and replace it with water, because during that initial combustion, it would turn the water into steam just as well as it turned the gasoline into vapor. You get an additional side effect. First of all, the water tends to enhance the combustion of gasoline. I'll get into that in just a second. And that's actually a very important point for today's talk, and so we'll be back. But what happens is when water turns into steam, it expands 1,500 times. So at the same time as the water turning into steam and quenching the flame, just like a fire hose steam from a fire truck, and then thus cooling the flame by not having a burning going out the exhaust. At the same time, the water expansion gives a push to the piston that the expanding vapors, gasoline vapors, wouldn't do because they only expand 300 or 400 times. So you can actually get a power increase as well as a pollution decrease at the same time as a mileage increase by putting water injection into the engine. And that works on all internal combustion engines. Now, getting back to why water, the major reason why you can add water to an internal combustion engine and get a lot of increase comes with how water acting as a catalyst. With internal combustion engines, with the fuel, with the ordinary hydrocarbon fuels, you have, in this case, this is methane, where we have 1 carbon and 4 hydrocarbons. If we add carbons and hydrocarbons in a chain like this, we get, in this case, propane. Propane has 3 carbons and hydrogens around it like this. If we continue adding carbons, we can get up to what's called dodecane. Somewhere between 5 carbons and 12 carbons is a mixture called gasoline. If you take the 12 carbon ratio here, that's called dodecane, and dodecane has about 19,000 BTUs per pound. If you split this dodecane into methane, methane has about 16,000 BTUs per pound. Okay? But what you've done is you've made 12 methanes. Okay? Can you see that? If you split every single carbon, like so, now in this particular case you can see this carbon is all free by itself, and in this propane we've ended up with this methane and this methane. So we have, with 3 carbons, we've ended up with 2 methanes. But if you add water, water is 2 hydrogens and an oxygen. And when you split these bonds in the explosion, you've got these free hydrogens floating around, which then can complete the process with the extra carbons, and you end up with more methane actually developed in the whole process, the chemical mix. The extra hydrogens that are floating around actually help knock apart this fuel molecule and break it into combustible components, because you cannot take all these bonds have to break before they can actually be reformed into carbon dioxide. So we got CO2, okay, and the hydrogens form into water. So again, they're taking oxygen, extra oxygen from the air, and so you've got H2O and CO2 as the byproducts of perfect combustion. If there was no pollution, if you were burning in a nitrogen-free environment, for example, and we'll get into that in a little bit. So the byproducts of perfect combustion is already water and carbon dioxide. Now, the water isn't polluting our environment, but the carbon dioxide is. It's not a poisonous gas per se, but it's a greenhouse gas, and all of it that goes along with that. So, in this particular case, what happens is the water actually combines in here. Now, you can see that if you have octane, for example, which has C8, and then it would have it would be 18. H18, this would be octane. You can see that if you divide this hydrogens in half, you have 9. So if you're putting in 1 gallon of octane, you're getting out 9 gallons of water. Okay? This is people say if you put water in your fuel, water in your engine, you're going to make emulsification in your fuel, and it's going to like make a milky mixture, and your engine's going to be destroyed, and all that kind of thing. That's a myth. It's a big myth. If you pour water in the oil, it's going to do that sort of thing. And if you have loose rings, it's going to get water in the oil kind of thing, even just right from your gasoline. In fact, the PCV system, one of its major functions is to take the water vapors out of the engine. Before they had PCVs, they had what was called a road tube. You simply took those vapors that were coming out of the crankcase and just put them right down on the road. So all the oil and water and all the vapors and everything that were created inside the engine would just simply get put out into the environment. But they wanted to eliminate that as a pollution source, so that they to spit it back into the engine, which actually is a good thing if you can get rid of the oil that's coming in it, because that heavy oil in the combustion chamber causes carbon. So there's products that you can do to get rid of that, and if you log onto our website, you can get a hold of that kind of information. Back to what we're doing here. So for every gallon of gasoline we're putting in, because it has an average of octane, we're getting 9 gallons of water going through the engine. So you can see that putting in 10% of water with the fuel that's already going in the engine and then cutting back 10% on the liquid volume of fuel is no big thing as far as putting water into the engine. When you're putting in a 50% mixture of water to fuel, you're still putting in an insignificant amount, or rather not a very significant amount of the water, because what you've done is you've cut back the water being generated by the fuel by half, which is in this case 4.5 gallons, and if you're putting in a half a gallon of fuel and a half a gallon of water, then instead of having 9 gallons of water going through the engine, you only have 5, you see? Now that gets back to where we're doing with the longer hydrocarbons. In other words, if you were using diesel, you can use a larger percentage of water because you have the extra carbons and hydrogens to deal with it. You kind of get the relationship. So if you're using propane, then you don't have as much, you can't add as much water because the effect isn't there. So it turns out that if you're using electrolysis, I'll just go into this a little bit. Oh, just a quick little thing, just to show where high mileage is possible. As a side effect of this sort of stuff, it's a different book than we're writing. I call it a high mileage book. It'll probably be out next year. But you can see, if you end up with 10 times 16,000, okay, so you've got 160,000 BTUs, where before you only had 19,000 BTUs. You can obviously see that there's going to be a lot more, if you're only using 3 BTUs per stroke on a cylinder, you can go a lot farther on a gallon of gasoline. Okay, in this case, this gasoline, I'm looking at the heavy ends, but I'm just making it as an example. For some reason that I'm not quite sure of, the specific density of propane or even liquid methane is not that much less than diesel, for example. Dodecane has a specific density of 0.7, which is compared to water as 1, and methane is about 0.65. So you can see that the weight of the fuel in a specific volume stays about the same. So when we're saying 16,000 BTUs per pound, there's a lot of extra energy came in there from somewhere. Now there's a couple of reasons why that extra energy comes in, which I won't get into now, but the fact is you can go into the chemistry of organic chemistry books and actually see this sort of thing. But it isn't something that's taught to ordinary mechanics. So an ordinary mechanic would not know that the 14.7 to 1 air-fuel ratio that they're taught in school, and I'm an automotive technician, I went through all that kind of training. I know exactly what they're taught, and I specialized in fuel systems, and they do not teach what I'm telling you now. They teach 14.7 to 1 is the correct stoichiometric air-fuel ratio. What it actually is the correct pollution ratio based on what the car companies want to have going through the cars. Okay? So they took it a standard, industry standard, if you will, and then they teach all the mechanics the industry standard, and then if some poor inventor comes up to a mechanic, or let's say a poor investor that wants to say, does this inventor have anything? Well, the mechanic says, no, it can't work, because all his training says it can't. So it's a different kind of suppression that actually exists out there. So what's happening is, if you remember the combustion thing I was just telling you about before, where there's actually 2 combustions in the chamber, the gasoline cannot burn unless it's in a vapor state, and only a portion of the fuel is vapor when it actually burns. First of all, if you do the calculations, there's several levels of conspiracy thing happening here. I'm not going to say conspiracy, but I don't mean conspiracy directly. What I'm saying is misinformation, several levels. So anybody that wants to can take an internal combustion engine of a certain size, let's say 300 cubic feet per 300 cubic inch size, and you can calculate exactly how much air it's going to displace at a certain RPM. So if you take it at 2,000 RPM, it means that it will displace 300 cubic inches per revolution. And if it's turning at 2,000 RPM, that means the cylinder draws in air during that revolution a certain amount of air, and you can calculate how much air is going through the engine. Okay? Now, because when you figure it out, you actually find that the engine is running at a 56 to 1, usually somewhere between 45 and 60 to 1 air-fuel ratio. When you actually, somebody just sit down and actually figure it out. Okay, I have my car, it does 20 miles to the gallon, I'm doing 60 miles an hour, I'm doing it 2,000 RPM, I'm drawing in this amount of air, I went I went 60 miles, I used 3 gallons of gas, I used this amount of air, and it turns out to be somewhere between 45 and 60 to 1 air-fuel ratio on a mass ratio. So obviously the 14.7 to 1 air-fuel ratio is like garbage to begin with, right? Then you put on top of that the actual fuel that was burning that actually powered the car was the vapor fuel that was vapor when the spark plug fired, because the liquid fuel never had time to burn in time to power the vehicle. Because looking back at the actual chart, in an engine, because of the way that the piston moves on the crankcase, on the crankshaft, and the way the journal is. So here's the actual crankshaft here, and this is the journal that throws the piston up and down. This is a reciprocating piston. So that means, in absolute physics terms, that at the top dead center and at bottom dead center, the piston must be, at some instantaneous time, absolutely zero motion, feet per second. Absolute zero. It has to stop and start moving the other way. So what ends up happening is the piston stops, speeds up, slows down, stops, speeds up, slows down, stops as it goes up and down. Okay? Now, it's already slowing down big time as it comes up close to the top dead center, and usually the ignition takes place at some point before the piston reaches top dead center so that the gasoline has time to explode. There's several different rates of burning. There's oxidation, which is just a rusting like an iron, and then there's burning, like you can see in an ordinary flame, and this is the kind of burn that all the calculations are done on, and I call it open burner technology. And then you get into what I call closed cylinder technology, which is an entirely different, even though we're using the same fuel, an entirely different combustion process. Now it takes a little time to burn here. So as the piston continues up, that burn starts to make a pressure in the cylinder, which as an explosion, you actually get more energy out of a particular BTUs than you do in a burn. If you just have an open air burner technology, the flame is burning out here, you're heating up air at a certain BTU rate, that's all fine. But if you take that same energy and put it in a cylinder and explode it, a lot more things happen. Okay, let's give an example. 3 BTUs is about the amount of energy that's in a stick of dynamite. 3 BTUs is also about the amount of energy that's put in an ordinary cylinder charge. If you put a stick of dynamite in there and exploded it, you would expect to find that piston in the pavement somewhere. Yet that's the exact same energy in BTUs that the piston goes up and down millions and millions of times during the life of the engine. You can see? Speed is the essential ingredient here. You can use a lot less fuel if you can burn it faster. And hydrogen allows the gasoline to burn not only more consistently, but faster, because it acts as that catalyst. So what's happening is, we're starting here before top dead center. As the piston is moving up to top dead center, there's a pressure being built, and the vapor is being burned, and then the piston moves past top dead center, and the pressure that's been done and continues to push against the piston. We're talking 200-300 psi, depending on the kind of piston and engine. And after about 12 degrees past top dead center, the piston is now moving faster than the speed of combustion of gasoline. Okay? So the only push that we're getting is a residual push of the pressure that was already built up in there, so it's acting like a spring, and the piston just flies down. Its major way that you convert the heat energy into mechanical energy is up when the piston is in that first 10 degrees of acceleration. After that, the fuel is still burning, or can still be burning, but it really isn't pushing the piston anymore. At that particular point, in fact, the quenching process is happening. okay, either by fuel or whatever. If you're burning pure gasoline, then by 12 degrees past top dead center, the gasoline is pure vapor gasoline, I should say. It's completely burnt. There is no additional fuel being burnt. And the combustion process is completely clean. Now, I have put pure, what I call Brown's gas, into cylinders and had it burn, and the engine purrs so quiet and smooth running on Brown's gas. But Brown's gas is essentially, you can think of it as hydrogen and oxygen mixture. It requires huge quantities of it to make the engine burn, and we can't generate that kind of quantities. But one of the things we can do is generate the quantities of gas necessary to enhance the combustion of petrochemicals, okay? Because of all the things I've just been telling you, we can actually get more power out of the fuel, out of the engine ultimately, than it cost us to make the Brown's gas, okay? Now I'm calling it Brown's gas because in this particular case my definition of Brown's gas is the total mixture of gas that comes out of an electrolyzer where you're not separating the gases. So it's oxygen and hydrogen and whatever else kind of gases, water, moisture, that sort of thing. So, what happens is, ordinarily, you have an internal combustion engine which is about 25% efficient, which means that you have to put about 4 units of fuel into this engine to get 1 watt out. But that 1 watt is going over here to an alternator through a fan belt, which is only, again, a certain amount of efficient. So we end up putting, in order to get a total of 1 watt out of actual usable power out of an alternator, we end up putting 5 watts of fuel into the engine, okay? So there's 5 watts of fuel, and we only got 1 watt out. We take that 1 watt of electrical power, and we put it into a Brown's gas electrolyzer, which is on board, and we get essentially 1 watt of gas come out, because there's no overunity here, okay? Now that 1 watt of gas, we feed back into the engine, and it actually increases the power by more than 5 watts because of the catalytic action that this gas has with the fuel, okay? So we end up with about 6 watts of power coming out, of which we can then use 5 of these watts back into the system to keep the thing going, and we end up with a net gain of about 1 watt, which turns out in actual real life to be about a 20% increase in the economy. And by putting this water in there, we actually have a decrease in pollution and fuel consumption at the same time as having an increase in power, okay? So the onboard electrolyzer with Brown's gas is an excellent way of using water as a fuel. In today's automobiles, just do it, okay? There's 2 different things that we've been talking about already. The first one is to just add water injection straight in. Just mist the water right into the air that's going into the engine, and it will increase the efficiency of combustion just because it's water. But if you split the water into hydrogen and oxygen, you get a further gain. There's an ordinary just putting in water, generally speaking, will clean the engine, enhance the combustion, but you won't get a large power gain or a large economy increase. We're looking at somewhere in the order of usually about 5%, although I have heard wild stories of up to 40 or 50% increases in mileage, that sort of thing. And I believe those to be true in certain cases, because there's certain catalytic action that happens in certain cases, like if you had the nickel plating in the cylinder, for example, then you would get that catalytic action and you get a lot more stuff happening. But just with the straight water, you're getting like 5%. If you put a Brown's gas electrolyzer on, then you're going to get about a 20% increase. Because what's happened is you put the water into the cylinder in a highly energized state. You've already split it. So the cylinder doesn't have to split it, and it doesn't have to wait until the combustion process starts to split it. So the whole catalytic action starts sooner. So you can get the whole fuel thing going sooner. Now, we call that technology, Eagle Research here calls that technology the HYZOR technology, and I'm just writing a book on that, which will be finished sometime in late October, I'm thinking at this time. The book is mostly written. I just have to put in this pictures and stuff so that people like myself can actually understand it. It's a bane of mechanics that, generally speaking, mechanical-minded people learn things more when they actually can see it hands-on or see a picture of it. When they say a picture's worth 1,000 words, they were certainly thinking of mechanically inclined people. So, in this particular case, we're talking about that. Now, if I was running an engine directly on Brown's gas, it takes a huge amount of gas to run. If I'm running it on petrol fuel, I can add a very tiny amount of Brown's gas. Now, you remember this chart that I just did here. This is a very, very important point, okay? As we discovered all these, for about 12 years, like I was saying, we were researching this particular kind of technology. We finally figured out a method of figuring out how much of this Brown's gas you have to put in the engine to get your maximum catalytic effect, okay? Now, you build your Brown's gas electrolyzer, and people think, oh, a little is good, a lot is better. That is not so, big time, okay? When you think about it, a vehicle going down the road at 2,000 RPM puts through hundreds of cubic feet an hour of air through the engine. Hundreds of cubic feet. Yet what we're doing is we're looking at an order of about 2 cubic feet of hydrogen going in with this hundreds of cubic feet. So you're talking like a 1% of a 1% of the air going into the engine has this Brown's gas in it, okay? But that teeny amount is enough to cause this 20% increase in mileage. And so, again, when you're looking at your whole total system, there's what's called a law of diminishing returns. We start out by putting 5 watts into the engine, and we end up getting 6 watts back. Okay? Now that generates about 50 liters per hour of the Brown's gas. So we say, oh, wow, okay, we got a 20% increase. We put in 5 watts, we get this back out. If we put in 10 watts, we'll get even more increase. But it isn't so. Because the 50 liters an hour in this particular case is the maximum amount of gas to get the most efficiency out of the catalytic action. And if you add more gas, you just get no more efficiency. So what's happening is you're putting in 10 watts, and you're still only getting 6 watts out. So suddenly, you're putting in, your fuel economy goes down because you're using more fuel and getting no more gain. You see the difference? So now in this case, you put in 10 watts and you get 100 liters per hour, but you didn't get any additional gain. Now, I can't say that in any particular case, in our experience, I have some charts and stuff that'll come out in the Heisler manual, but this will give you a bit of an idea. Generally speaking, 350 engine would use about 10 amps. And then you could just rate that up and down in that kind of arrangement. Now, another thing that we've been experimenting with is increasing the efficiency of the alternator itself. We can make the alternator gain about a 20% efficiency. So suddenly, our 5 watts that we're putting in, we may not have to put in 5 watts and to get the 50 liters an hour, and we gain 2 units out because we didn't have to have that wattage come back around, you see. So these are the kind of things that we're doing in the Heisler manual to make the water as fuel in a supplementary sense, okay? Now, there's other technologies where you can use water as a fuel and not have to have it in a supplementary sense. I've been talking about using water all this time in combination with petrol fuels, but there's ways of using water as a fuel all by itself. For example, hydrogen peroxide, okay? Hydrogen peroxide, what you're able to do, now you can add it to the fuel mixture similar to what, if you're just adding water, you can add hydrogen peroxide as well, and it gives extra oxygen and gives a boost and all that kind of stuff, but that's not what we're talking about. And in this case, we're not dealing with the internal combustion engine anymore either. We changed it to a steam engine, okay? And you can make a steam engine. There are steam engines out there already. They're about the size of a gallon coffee can and put out 150 horsepower. And what you've done, you've eliminated the cams, the crankshaft, you've eliminated the oil, essentially most of the oil cooling, the cooling system, like you don't need a radiator or anything like that. All the things that make an engine bulky and heavy, you've eliminated. and you've gone right down to a rotary device which can just directly power the vehicle, or you can have it power an electric generator and have a hybrid engine or any of those sort of things. So you can have a engine that weighs somewhere around 70 pounds instead of 450 pounds and puts out the same horsepower if you're using the steam. And the way you do it with the steam, with hydrogen peroxide, is you have hydrogen peroxide in your tank. Of course, you have to use a tank that's compatible with hydrogen peroxide, and you're using hydrogen peroxide of 70 to 90 strength, so it isn't something you want to be spilling on your skin, okay? Because it'll just dissolve it. By volume, that's right. That's right, 70 to 90% hydrogen peroxide. I'm not saying that this fuel is safe, but I am saying that it's totally inorganic, meaning that if you have air and water and electricity, you can make as much of this hydrogen peroxide as you want. And we're working on means that people can just make it at home. So once you can make this thing at home, or even if the unit ends up being small enough, you can carry it with you and you can make your fuel wherever you go, where you can find water and air and electricity. You can have, you can just disconnect from the economy of oil consumers. Now, again, you have to be very careful to handle this fuel safely. But as you feed the hydrogen peroxide onto a grid of copper or platinum or any of the catalyzing things that will cause the oxygen to jump off the hydrogen, essentially, hydrogen peroxide is H2O2. So instead of H2O, it's H2O2. So you have an extra oxygen on the water. All you've done is attach that extra oxygen on the water. And when you release that extra oxygen, it releases a huge amount of heat, which turns both the water into a gas, and of course the oxygen itself is a gas. So now you've suddenly gone from a liquid to a gas, very high temperatures, so it turns into steam, and the steam can drive the steam turbine.
Is that like flash vaporize?
Yes, it flash turns into steam just as soon as so you just have to have a little valve. You've pressurized your hydrogen peroxide. You just have to have a little valve on your throttle that controls the amount of hydrogen peroxide that's being sprayed onto the screen, and poof, you've got the steam instantaneously. And of course the byproducts going out into the atmosphere are oxygen and water. That's it. You have no nitrogen in the system at all. You're not combusting anything, and so you have zero pollution as far as that goes. Okay, it's just coming right out. It's just steam. Okay. Now they're actually producing helicopters. There's a company called AZ Industries in Hardy, Arkansas, which is producing helicopters along this idea. And they've just discovered a way to enhance that effect by adding alcohol to the process. And because when the alcohol is combined with the oxygen, well, then there is a combustion process, but you end up with a whole lot of extra BTUs and extra steam as well, because you've burned the alcohol and gotten more water and that kind of thing. But you're still doing it in an environment that doesn't have any nitrogen, so there isn't any nitrous oxides or pollution along those lines being produced. And alcohol is what I call an eco-fuel. Okay, in fact, it's what I call a biofuel, which is a subdivision of eco-fuels. Hydrogen peroxide would be an eco-fuel because it's a fuel that's good for the ecological state of the earth, and alcohol being a biofuel because it's biologically made eco-fuel. And biofuels are defined as fuels that are in one life cycle reconstituted. So the corn grows, for example, and then you make the alcohol out of it, and then you use the alcohol, and you get the rotting process or burning process or whatever. The carbon is released into the atmosphere, and the next corn stalk that comes up, because of the seeds of the corn and stuff, takes that carbons back out of the atmosphere, so you end up with a net no change in the oxygen level of the planet. Like if you're burning hydrocarbon fuels, petrofuels, you're taking that carbon that's been stored and you're putting it into the atmosphere without taking it back out and storing it again. So that's what I call a biofuel. So in Hardy, Arkansas, that's one way of doing it. Ma'am? Yes, okay, you got it. I answered your question, that's good. Okay, so another thing is, as I said a little bit with the live water and the orgone energy, Another way of using just straight water, and we're thinking it's Oregon energy, that there are people who have replicated this. This one man, codenamed Joe in Australia, developed what he was wanting to do is make a steam car out of his internal combustion engine. And he was going to use 12 volts in pure water, and he built a little stainless steel tube about 18 inches long with a rod inside, another tube inside that had lots of holes in it, so he had about the same surface area from the inner and the outer tube, and he polarized one positive and the other negative, and he plugged it into 12 volts, and he saw this white vapor coming off, and he took that hose and put it onto a plug on his engine that was underneath his carburetor, and started running his engine, and when he shut off his engine, it turned off the key. Let's see, when he turned off the key, it stopped, that's right. But before he turned off the key, what he did is he turned off the electricity to his steam generator, okay? So it would stop producing steam and the engine would stop. But the engine didn't stop. The engine just kept going and going and going and going. And it was running a little rough, so what he did was he advanced the timing about 70 degrees, which if anyone knows about internal combustion engine, there's no way it can run at 70 degrees advanced. But it ran smoothly at 70 degrees advanced. So now he's kind of scratching his head a little bit, but he's thinking, okay, that's fine. And he had unplugged the power, and now he's starting to think something's not fine because the engine's still running. And then later, when he shut off the key, the engine shut off, so well, it's a big sigh of relief. At least I can stop this thing. And he could start it and stop it, and it would continue to run. Now, all this time he's doing this with no fuel going into the engine through the regular carburetor. And then he discovers that there's no gas going from his steam generator into the engine either, because what was that nipple that he had plugged the hose onto was blind. Okay, it went in. There was a hole there, but it was solid aluminum on the backside. So there was no direct access for the steam or any other vapors or anything to go into the engine. And it's been discovered that the aluminum and water tend to gather this Oregon energy, which is, again, what we were talking about. And so aluminum engines become charged fairly quickly with this Oregon energy, and then you can run it using this kind of electrolyzer device that Joe has developed. And there's a worldwide interest and hundreds of people working on this particular technology now, and getting some people with limited success, and I guess, as I understand it about this time, about 15 or 20 people who have actually ran engines on these type of cells, which is, there's no fuel going into the engine at all except this energy that's being absorbed into the water and then transmitted into the engine. Cast iron engines take about 3 weeks to charge, 3 to 4 weeks. So you don't see very many of these things working on cast iron engines. They're mostly on aluminum engines, which can charge in minutes or maybe up to 3 hours kind of thing. For some reason, the aluminum does that really well. So that's about all I have to say on that. I don't know exactly what more there is. Another way of running directly on water is a thermal way. If you heat water up to a high enough temperature, it will split into hydrogen and oxygen, and then the hydrogen and oxygen can be burned in the engine. And there was some really good success in France and in the Midwest with inventors who took the exhaust heat and recirculated that by causing the temperatures to split the water, and then having the water go into the engine and be burned, and then it would come out as a lower energy, and then the heat, but with some additional heat, and then they kept the cycle going. Now, I'm not sure exactly how it was done. I have patents that I've looked at and not fully understood, but what I'm doing here is reporting on the things that have happened so that other people can continue along that same sort of line. I know that when you put water in with a fuel, you get a huge enhancement in the amount of BTUs that the fuel puts out. For example, I had a vortex burner that I just wanted to be able to burn used oil. And so what I did is I took a coffee can and I blew air in at an angle at the bottom of the can, and I just dumped some used oil in there and threw down a piece of Kleenex and lit the piece of Kleenex, which then acted as a wick and started the oil burning, and eventually the can got hot. It didn't take too long. and the air blowing in provided the combustion air that was necessary, and I got a little tornado of flame inside this coffee can. And then I could just keep dripping in used oil, and it would be nothing but heat coming out. There was no smoke. You could just see the heat waves coming out. Because the actual liquid oil was thrown to the outside of the can by the centrifugal force, and then the heat from the vortex, the tornado of flame, would radiate over and vaporize the fuel, and the fuel vapors would come to the center and burn, and then eventually the byproducts would go out. This isn't a new technology I've discovered, but it is a very efficient one. But I was doing this in the wintertime, and in Canada, on a steel table, and I just cleared away some of the snow, and the snow melted away from the gallon can about 4 or 5 inches as this thing was burning, which it was fairly cold at the time. We're talking about 10 degrees below centigrade, and so that was a fair amount of heat coming out of that little heater, even though it's just dripping in the used oil. Used oil actually has more BTUs per pound than diesel because it's a heavier oil and that sort of thing. But nevertheless, what I did just for fun is I grabbed a snowball and I threw it into the machine, into this vortex, and it practically exploded. Okay, the flame just roared, and the heat melted away 18 inches away from the can. Now, anybody that knows inverse square law knows that we had a serious amount more heat coming out of that can than the original stuff. So adding water helps. There was a fellow down here in Texas that was running what he called the super steam technology, and what he was doing is he was putting in propane or natural gas in some cases, and creating a vortex in there, a vortex flame, which then he would add, and he was putting in oxygen obviously, and then he would add some water to that, and he was saying he was getting like 10 times over unity compared to the amount of heat that he was putting in. So the amount of heat that he was getting out for his steam generation had to do with this additional catalytic effect that I was talking about before. So again, those are burning the water with petrochemicals, but it turns out that these where you just use the water once it's burning to heat itself, to keep the combustion process going, if you can get the process hot enough, it will keep going. The water will combust itself and split itself and burn itself and provide a more or less perpetual kind of a thing happening. In this case, they were actually recovering the steam that was coming out of the engine, so they're recovering the heat that was coming out of the engine. So you had an engine that had no exhaust, and once they got it hot enough, it would just run. Now, this was well documented in France and also well documented in I think it was Utah. It's written in the book here. But what happened is, in Utah, for example, there was a senator that went down, and they were not only putting it in engines. In fact, their major thing was to put it in furnaces to heat homes. And so they were heating homes with water. Okay? So this is another way of doing it. Another way of going about it is to use lye and aluminum. Now, there's a lot of different chemical reactions along this sort of way, but this is one of the most common. And I first learned about it by a similar thing that I was talking to you about before, where I sent out information and then people get back to me on various things that they know. And this, I'm going to say a redneck in Tennessee got a hold of me and said, hey, we've been running on the beer cans, running our vehicles on beer cans, because the beer cans are made out of aluminum, and they just take a pressure cooker. I imagine their wives didn't appreciate it very much. And they put it in the back of their vehicle, and they didn't have a lot of money for fuel, and they discovered that if they put lye, which they could get from wood ashes and what have you, and mix it with water, and then throw in these beer cans into this container and seal the lid, it'd build a pressure, and when it got up to about 70 psi, they could feed that into their carburation system, and they could travel a fair distance on the hydrogen that was being generated. Now, what happens is the aluminum turns into aluminum oxide, because when this process splits the water, the lye is a catalyst. It just stays in there. It's no big deal. But the aluminum turns into aluminum oxide because it takes the oxygen from the water. And the two hydrogens are just released as a gas. And the hydrogens then, of course, can go out and power the internal combustion engine. So you end up running the internal combustion engine on aluminum, and there's a lot of aluminum around, and you can take this aluminum oxide and turn it back into aluminum. So it takes a fair amount of power to do this, but it is possible to do it. And of course, then you're running on the power of the aluminum, I guess is another way of looking at it, and using the water as a medium. But this is a practical technology. It was actually experimented with Mercedes-Benz, if I remember correctly, and over in Europe. And it was, what they'd done is they'd taken a wire feed welder, and they had the aluminum wire feeding into this machine, which would then they also used electrolysis or electrical means to help it along, because the aluminum oxide is very resistant to electricity and also to chemical action.